Okay, so looking at the laws or properties of logarithms, we're going to be using them to condense and expand some logarithmic expressions, and then really the goal is to be able to use them to solve some equations, okay? So a couple basic properties. We've kind of already seen these at play yesterday. What would log base b of 1 always equal?
0.
0, yes. That's because b to the 0 power is always going to be 1, right? How about log base b of b? 1. That's because b to the first power would be itself, right? I think those are pretty intuitive. Okay, now, next page. These are laws or properties of logarithms. Within these properties, I'm going to use the letters m, n, and b. Those are all positive real numbers. B is going to be the base of my logarithms. So I'm going to say that in addition to B having to be positive, it's not allowed to be 1. Okay. And then one of the properties at the end there uses K. That's going to be any real number. Okay. So property 1 we saw yesterday. B to the power log base B of m. That's just going to be m, right? Property 2, log base b of b to the power of r, just going to be r. All right, and then the next 3 properties are the 3 main properties of logs. So we have the product property. It says within the logarithm, if the argument can be thought of as a product, of this case m and n, we can break this up into 2 logs that are being added together. This is equivalent to log base b of m plus log base b of n. Okay, now let's justify that. So again, the argument there is m times n. Let's say m is thought of as b to the power of x, and n is b to the power of y. What would you do with the powers of x and y when we're multiplying there? What do you mean combine? Add them, yes. Okay, so you end up with b to the power of x plus y. Well, understand that would be x, and that would be y, wouldn't it? So they're just being added together. Okay. All right, so quotient property is similar. Log base b of m divided by n. This would be equivalent to log base b of m minus log base b of n. Okay, similar reasoning. If I have m divided by n, I could think of m as b to the power of x, n as b to the power of y, and we know quotient property of exponents says to subtract those exponents, numerator minus denominator, right? So once again, log base b of m is my x, log base b of n is my y. They are being subtracted. All right, now the last property, this is the big one. The power property is, in my opinion, what makes logarithms worth studying, okay? Here we've got log base b of m raised to the power of k. Remember, k can be any number, any real number. This property says you can bring k in front and multiply it by log base b of m. All right, now kind of the reasoning of that. Let's say we start with m to the power of k, but m we call b to the power of x. Well, what do you do with the power of x and the power of k there? You multiply them. And that's exactly what's going on here because, again, log base b of m is x. I have x times k. All right? All right, so the next couple pages are just examples to get us used to using these properties. All right? So example 1, these would be of the easy variety. I want to expand using properties of logs. Well, expand means make bigger, right? Or make longer. So I'm going from a single log to multiple logs, probably added or subtracted. Okay, well, natural log of x squared y, there's a product there between the x squared and the y, right? So I can use a product property and make this into natural log of x squared plus the natural log of y. Then I can use a power property to bring the 2 down to multiply the natural log of x. And that's as expanded as that one can get. Next, we have common log of the square root of a divided by b. I'm going to make that the common log of the square root of a minus the common log of b using my quotient property. Now, square root of a we know is the same as a to the half power, right? So I could apply a power property, bring that in front to multiply common log of a. So certainly okay to leave it like that. A lot of times you'll see this written as log a all divided by 2 minus log b. Now go in the other direction. Condense using your properties of logs. When we condense, we make things smaller, right? So we're going from multiple logs added or subtracted together to a single log, okay? So I see addition here between these logs. I know to multiply them together, the arguments. Okay, and I'll actually multiply that out and end up with x squared plus 2x. Parentheses are absolutely necessary there around the argument. Okay, log base 2 of x divided by 3. Isn't that the same as log base 2 of x to the 1/3? Minus your log base 2 of 5. Well, x to the 1/3 is the cube root of x. And then because we're subtracting with the second log, I can use a quotient property and make this into the cube root of x divided by 5. Questions? All right, so again, those are more of what I consider the easy variety. So now let's go to some harder ones with just more steps. All right, expand into a sum and difference of logs, expressing powers as factors. So when we say express powers as factors, factors are multiplying each other, right? So this just means use the power property, okay? Understand in a fraction like this, it's kind of like there's grouping symbols around the numerator and the denominator, right? So the first thing I'm going to do is handle the quotient. I'm going to make this log base a of the cube root of x squared plus 2 minus log base a of x to the 4th times x plus 2 cubed. All right, now cube root of the x squared plus 2, I can treat that like a power that comes out in front and multiplies the log base a of now x squared plus 2. Okay, and then that second logarithm, notice there's still a product within that argument. X to the 4th is multiplying x plus 2 to the 3rd. So I can expand this to 2 more logs, okay? But when I do that, I got to be careful. This subtraction here applies to that entire log, right? So if I expand this into 2 more logs, I'm going to need that subtraction to distribute. So I'm going to use parentheses here. And initially, I'll say this is going to expand to log base a of x to the 4th plus log base a of x plus 2 to the 3rd. But when I go to simplify, that negative is going to distribute. And about the only other thing I can do here is some more power properties. So we'll make this minus 4 times log base a of x minus 3 times log base a of x plus 2. So this is key right here. That guy. Make sure you have that as negative. Initially, it should have been addition, but we have to distribute that negative to turn it to subtraction. That's as expanded as we can make that one. All right, next we condense to a single log. Let's do power property first. Make that log base 3 of the cube root of x to the 21st. Now, what is the cube root of x to the 21st equivalent to? X to the 7th. Good. All right, now I just go from left to right. I see addition between the first two logs, so I can multiply their arguments, make this log base 3 of 9x to the 9th minus log base 3 of 9. And then use a quotient property. Let's make that log base 3 of 9x to the 9th divided by 9, which of course I can reduce. Make that log base 3 of simply x to the 9th. Questions on either of those examples? Won't get much more sophisticated than those two. All right, well, let's try to get at least part of example 3 in here. Okay, so a couple more laws or properties here. If m equals n, then log base b of m equals log base b of n. All right, so that's a big one. That's saying I can essentially use a logarithm as an operation on both sides of an equation. And then 7 is just the opposite of that. If two logs are equal to each other and have the same base, then their arguments are equal. Okay, so solve these equations, check for extraneous solutions. Let's just do the first one. Power property, two logs with the same base equal to each other, their arguments are equal. I'm going to get 4 or negative 4, but negative 4 would be ruled out in this case. Why? It would make this logarithm undefined. Log base 4 of negative 4 is undefined, so 4 is our only solution.